Hey everybody, it's Mr. Barth again. We're going to try some two-step equations with combining like terms. Okay, this is another complication that we can run into sometimes with solving equations. And it just takes an extra step or two to get to the two-step equations that we're used to. Okay, here's a typical example. And this doesn't quite look like a two-step equation. And the reality is we have to take a quick step before it looks the way we want it to, or the way that we're used to having it look. All right, and that simply means that we have to take some of these like terms on one side and combine them before we get into our solving. All right, so in this particular case, I'm going to take my 4z and my 4z. Some people like to box these so they know what terms they're combining. Like we'll do boxes and circles and triangles. I'll show the box way. Maybe I'll show it a different way for one of the other examples, but this is pretty straightforward. Okay, so I got my 4z and 4z. And remember, I'm adding the coefficients. Okay, I get 8z plus 7 equals -1. Looks like my lawn mowing guy is going to come by the window right in the middle of this video. I apologize for that. Now I have my two-step equation. Okay, and I simply solve from here. Subtract 7, cancels, and I get 8z equals -8. Hold on a second. Sorry about that. Divide by 8. Divide by 8, cancels, z equals -1. All right, that's about as basic as an example as I can give. So let's get some more complicated ones. All right, we're going to combine these like terms here. All right, so I'm going to box up the ones I'm going to combine. So these are all the ones with x's, and these are all my constants. I'm going to add those. 3x plus 4x is 7x. 5 plus -3 is 2. Okay, and now this looks like a two-step equation. All right, so I'm going to add -2 to each side. You can call that subtracting 2 if you'd like, doesn't make any difference. 7x equals 21. This is a multiplication, one-step equation. And I'm going to divide both sides by 7. Now, don't forget, if I take and I put these back in to the original equation, if I take this value that I've come up with, now what I'm saying is when I get this value of x, I'm saying that this value of x is the only value of x that is going to make this original equation a true statement. Okay? So you can always take this and plug it back in if you're unsure. Okay, it's a good way to check. It's a great habit to get into. Let's try it real quick. If I put 3 up here, this is 3 times 3, that's 9. See, I don't want to run over here. Plus the constant, that's the 5. And if I put 3 in there, 4 times 3 is 12. And then I'm going to subtract 3. And all that has to equal 23. If this is not a true statement, then I haven't solved the problem correctly. Okay, so let's go. 9 plus 5, that's 14, plus 12 is 26. 26 minus 3, fortunately for us, is 23, and I know I have the right answer. Okay, you can always go back and do that. All right, let's try one. I threw a little loop at you here because I think a lot of kids forget this, or this is where problems are created. All right, so again, I am going to box up those terms that all have my variable in them, same variable. This last one here is an interesting one. When you are subtracting a variable that has no coefficient, it's in your best interest, and it's an easy way to remember, always put a 1 in front of it. Okay, because if I'm subtracting 1, I'm basically subtracting 1m. Or if I'm subtracting m, I'm subtracting 1m. Okay, so I'm going to add all these up. Negative 6m, negative. Now, some of you like to change these additions into, change these subtractions into adding the opposite, and that's fine. If you want to go down here and go, subtracting 10, that's adding negative 10. Subtracting 4m, that's adding negative 4m. Subtracting 1m, that's adding negative 1m. That's fine. I prefer to do that. I find kids make less mistakes that way. Okay, so now I have negative 6m, negative 4m, negative 1m. All those add up to negative 6, negative 4, negative 1. They'll up to negative 11m. Okay, and then I'm going to circle these two. I have negative 10 and 2. They are opposite signs, so I'm going to subtract them and keep the sign larger. 10 minus 2 is 8, and the negative, that's my larger absolute value there. So, and that all equals 25. Now I can go from here. Now this looks like a two-step equation, and that's our goal. Okay, you make these bigger, more complicated things look like something we're familiar with. So I'm going to add 8, cancels, negative 11m equals 33, divide both sides by negative 11. Make sure you're dividing by, if the coefficient's negative, you have to divide by something negative so that this becomes this 1 here again. Okay, and I end up with m equals negative 3. And if I put this back in here, okay, it's going to come out to a true statement. And go ahead, test it. All right, here's one last example. Oops, I know we're running out of a little bit of room here, so let me see if I can switch this up just a bit without causing a camera catastrophe. All right, I put the variables on the right-hand side. Some of you guys are patently uncomfortable with this, but we're going to do it anyways. So I'm going to change these all to additions in here. So this is adding negative 9k, adding negative 3k, adding negative 1k, and adding negative 3. Okay, now I'm going to combine all these like terms, all the variables with k in them, and I will add their coefficients. So I have 4, let's see, let's make this easy here. Negative 3 and negative 1, that's negative 4k, and 4k, let's see, 4k plus negative 4k, well those all cancel out, that's 0k. So these all add up to 0k, and I'm left with negative 9k. All right, I have 12 plus negative 3. They're opposite signs. When I add them, I have to subtract 12 minus 3, and I get 9. And I keep the sign larger, that's 12, so this is plus 9. Okay, and there's my two-step equation that we're used to. Add negative 9, add negative 9, cancels, and I get negative 9k equals 72. Divide both sides by negative 9. I get negative 8. There you go. It's perfectly acceptable to rewind this a number of times if you have to. So have a great day. Good luck with two-step equations with combining like terms.